Hello everybody, this is going to be a video explaining how I made a Ambasonic microphone from scratch, and that includes the actual electronics, the 4-channel recorder, and the actual Ambasonic body that you 3D print. Hello, I'm SN60PB40 and I'm a hobbyist probably just like you. So what exactly is an Ambasonic microphone? It's basically a binaural microphone on steroids, kind of. If you don't know what a binaural microphone is, it is basically those weird ears on a stand, if you've ever seen those before, where they record something or whatever's going on and they make it seem, when you wear headphones, like you're actually listening to whatever it was recorded on. Like you're in front of them, you close your eyes, you can hear like rustling paper on the left, on the right, whatever. And a Ambasonic mic takes that to the next level because you can add post-processing to that. Downside is that you need to use a Ambasonic audio editor like Reaper, but on the plus, you can do so much more compared to just a binaural microphone. For example, you can beamform, which is you select, let's say, from 10 degrees to 30 degrees, you only want audio from that specific angle when you were recording. That's possible. You can do head-tracked spatial audio, so BR stuff. You can reorient audio in post-processing. You can downmix the stereo 5.1, 7.1, or even 22.2, and a whole lot more, which I'm not going to get into, but it's really powerful. First thing, why did I make this project? Because I just wanted to play around with Ambasonics, and I wanted to make a microphone, and I went to look at how much Ambasonic microphones cost, and they are crazy expensive, and I mean crazy expensive. And if you're not even counting the actual recorder, because you need a 4-channel recorder, your computer probably does at most 2 channels built into your motherboard, but that's not practical. You can't take your whole computer with you, and phones only do 1 channel, possibly 2 channels, but not via aux inputs. So yeah, it's kind of expensive, and I wanted to change that, so it's pretty cheap. So I took the cheapest components off AliExpress. I bundled something up. It costs 20-ish pounds to make, depending on the components and such you choose. I just did this as a proof of concept, so the capsules I used are really garbage, and all the components are just enough for it to work, but they won't be amazingly clear. If I make a second version, then I'll definitely fix up on those parts and make it actually very, very usable, hopefully. For the actual Ambasonic microphone, you only really need a aux connector to a cable, of course, and the actual capsules. There is also a 14.60mm hole version, so not 16.2mm version, which is meant to fit the Primo EM204, which costs around about £100 for a set of 4, which is a whole lot better than the ones I'm currently using, but I just wanted to make a proof of concept as of right now. So the actual recorder, I will also give a warning. Currently the firmware isn't super well. It works, but it doesn't work very well enough to show the actual working thing because, well, I was already hesitating on actually making this video, but I'm gonna make it. Worst case, you have the actual Ambasonic head, which by itself is a project of itself, but I wanted to go a step further and make the actual electronics as well for it. The components that I used is a ESP32S3 mini, but you could go with any single one. I chose the Wemos one. PCM 1808. Use 2 of them because they're both 2-channel. You need 4 channels, so yeah. 2 aux cables and 4 aux female pins. It records to an SD card, so you need an SD card little module holder thing, a tiny OLED display, and maybe or not microphone preamps, which I'm still working on whether you need or not. And of course some thin wires to solder everything, possibly resistor capacitors to make main sum go away if that's needed. There's much more info and a text version of this on GitHub, link in description, connection diagram on GitHub, everything so. Okay, so how did I go about actually connecting everything and how I know what to connect to what? Well, first thing I needed to pick a ESP, so I went through the datasheets and only the ESP32S3 has 2 I2S interfaces, excluding the P4, I think, but that's kind of expensive currently, and I wanted to make it cheap as possible. We can also go onto the expressive docks for inter-IC sound, or if we want to be lazy, we can go over here to the actual general GPIO, and we can see that GPIO matrix exists, where it allows peripheral input signals that can be from any GPIO, basically saying I can take any pin as long as it's a input-output pin, and I can just connect it up, and then in firmware I actually define the pins. So that's what I did. I literally just put pins to whatever fit perfectly on the PCB. This isn't how the PCB looks. I just made this as an example to show you, and you can see that this is perfectly like next to each other because I did this just without any PCB. I just connected it up and it fits pretty decently in. This will be on OSHW Lab, link in description if anyone wants to have a look at the schematic themselves, edit it, do whatever they want with it, and it will also be on the GitHub. Currently I just have it that we have the aux connector going straight to here, but I might add a preamp. Still not sure about that part. With the SPI port, all I did was I just picked same any random ports. I know there are specific ports that I used for SD, but I just did it this way, just with whatever pins were closest to me and easiest to use. Same with the display story, like GPIO matrix is a very powerful thing for ESPs. And then here we connected VCC to 3.3 volts. 5 volts is 5 volts. You need both because 3.3 is logic, and 5 volts is the actual analog part. How about here? FMT MD1, MD0. Why do I have that grounded? Well, if we go over here to the actual PCM1808 ADC datasheet and we scroll down, we can see here we have MD1, MD0, and we have FMT. Well, we want I2S, so we have to set FMT low, so ground it. And if we do MD1 and MD0 as low, then it's in slave mode and it auto detects everything else. So it's the most universal thing we can go for. Plus we need slave mode since it's the slave. It's connected to a microcontroller, which would be the master. Hopefully I explained that in a decent way. Also the button, nothing special about that, just a button to a GPIO pin that's free over here. Okay, now how did I actually make the 3D model? There is a type of ambisonic microphone called the Tetrahedron microphone, and if we go to the Wikipedia page of that, we can see that we have instructions on how to calculate. Now, knowing that information, we can go from the start. First, we want to actually make the tetrahedral. We start by making a variable. I pick 36 millimeters because the capsules are 16 millimeters, and you want to double that and then add a little bit of room for the actual walls. And then now we want to do a calculation to see how tall the tetrahedral needs to be, which is the square root of 2 divided by 3 times the side, and the side being 36 millimeters. Doing that, now we can make a sketch on the top plane, and we just make a inscribed polygon. We set it to whatever size, then we do it so it's a triangle, and from there we can select the side as hashtag side, and from there we want to make a second sketch, which is going to be on the front or right plane, and we want to make it the hashtag tall, which will be 29 point whatever. We just put hashtag tall in there, and that's it. From there we can make a loft where we select the base sketch, and then we select the point at the top, and then it makes a tetrahedral. We can test if it truly is a tetrahedral two ways. One side is you check what the area is on one side and then the other side if it works, and then check the base as well. I can't do that because I made a chamfer right here, which I'll explain a little bit later. Okay, now that we have the actual tetrahedral, we want to make a sketch. So sketch 3 to 6 is going to be exactly the same, where it's a circle. You want to actually make a 3-point circle since you don't have a center. Then we want to make the actual circles where the walls of the capsule holder will be, and then this is where the capsule actually will be. I put 14.6, which is exactly the measurement of the capsules I'm using, which is really tight, but I don't want them to fall out, so I had to do a little bit of manual sanding once I printed it out properly. And then you duplicate that for all 4 sides. Now from there we can extrude it. So as you see here, I started extruding it and it's starting to look slightly like the finished product. I also added extras in the center so they actually touch against each other properly and they have proper context. And then now that we have the base shape, which I can't show you, but here is the finished one, you can now test whether the tetrahedral is done properly by selecting 2 of the inner walls, and you can see 109.471 degrees, which is around about how much you should expect, 109.5-ish. So if that's right, then we know we have a tetrahedral properly done. And then from there on, I literally added fillets into the corners so it looks nicer and not as pointy. And now we need to actually make the arm for it. So what I did was, as you can probably now think, I made a chamfer into one of the corners and then I just made a sketch on it. Took me a little long to figure that out and kind of embarrassing, but oh well. Now from there I literally just extruded it, as you can kind of see here, and then I also made a circle in the center so that whites can go through the hole. Now the actual base, I just made a literal square, which is a box, and then I made the hat for it. Made the hat a little thicker so that the thread for the 1/4-inch tripod mount will not like push against the aux connectors, and it's just a basic box. There's just holes on the side for the aux connector to enter in, and then the big hole at the top for the actual pipe to slot in. I don't know what to call this part. And another thing is I added chamfers into the corners here so they don't interfere with the sound coming into the actual capsules. As you can see, they are a little more chamfered on the side right here. I also made these quite long, which make it hard to slot in, but it holds it in properly so it doesn't fall out once it's properly in. The room in here is barely enough to fit the actual aux connectors and the wires, but it fits. I'll also note the actual connectors I chose. If you actually do this build, they aren't the highest of quality. The thread inserts snap very easily. If I make a version 2, I will fix that and add different connectors, but for now, just have to deal with it. And for the actual thread, I just imported a custom feature called threads, and I just let it have the default settings that it suggested. Don't know if that's the right thread, but it fits properly on a tripod. As for printing it, I printed it facing up. So this thing was upside down, this thing was as is right now, and then this, if this bottom section is the floor, I printed it from this. So it looks like straight up like this one printing. And for the actual case where all the electronics are held, it's nothing too interesting really. It's same thing where I made a box, and then from there I made holes to fit perfectly the screen, the button, and then here I just measured out roughly where each part should go, and I just hope when I printed it, it actually fit and all fit properly just fine. Just nothing too interesting in this part. I'll also show the code, though I'm not really going to explain much because code's boring. First thing is libraries. All we have is the display library because that's all we need. We include all the libraries that are necessary. We define button, screen, pins, and other little stuff. Now we want to define the WAV header, which will basically say it's 4 channels and that it's a WAV. Next, configuring the I2S ports. So as I said earlier, with the defining with the GPIO matrix of the ESP, we're doing that here where we're defining each pin, GPIO number 35, 38, and so on and so on. Next, we get the file number. So for example, if code 1, 2, 3, 4, it counts and then it does the next file name. Then setup, this is basically starting everything that we defined earlier and it's setting it up pretty much. Intro, and then some little warnings in case, let's say, SPRAM ran away or it died. And then we begin SPI and I2S, everything. And then we just loop everything, which is going to wait until you press the button and then it first calculates like, okay, what number file do we have? Record 92, 98, and then it starts doing everything, which I won't get into, and then more and more and more, and that's pretty much it. Pretty short, not a lot of code for what it theoretically does, though, as I said earlier, it doesn't fully work just yet, so it's work in progress. If you somehow made it to the end, well, thank you for watching and listening to this rant. Hopefully, I showed you something that you didn't already know, and if this type of video, which is longer, more in-depth, is better, please do tell me, because I'm not sure if I just wasted my time and no one's going to watch this, or if this is going to get like at least 10 views. Hopefully it will. If you have any questions, or if you think I glossed over anything too little, ask in the comments. I will definitely expand on whatever you need to know. Thanks for watching, and I'll see you later. Bye.